Okay, so here is a study guide for what I think is chapter 4. It says write an expression equivalent to -8 times -8 times -8 times -8 times -8 using a positive exponent. So the key and the trick to this is the correct answer is going to be, this is called your base, and then you have the base multiplying itself 1, 2, 3, 4, 5 times itself. So we use that. That is -8 to the 5th power. Notice there's a quantity, because if we don't have that quantity, this is equivalent to -8 times -8 times -8, as we see -8. This, however, without the parentheses, is the opposite of 8 to the 5th. So the base in that example, the base of this exponent is 8. And then we take the opposite of 8 to the 5th because we're going to do exponents before multiplication. This negative is seen as multiplying the 8. So the correct answer for this problem is going to be the quantity of -8 to the 5th. So be careful that this one is the wrong answer that students typically write. Write the following expression using an exponent. So again, we are going to want to keep the parentheses, and it is to the 3rd. Since they are identical, it has to be identical. So you can't, if you have, 2 times -2 times 2 times 2 times -2, you can't write that as, -2 to the 1, 2, 3, 4, 5. That's not going to work. So the bases always have to be the same. It has to be the same number. So if you have b times b times b times b, that would be b to the 4th. They must be identical bases. Whatever you're multiplying has to be identical. So just a little thing to keep in mind. So since these are identical quantities, that's the quantity of 3x minus 5, that's the quantity of 3x minus 5, and that's the quantity of 3x minus 5. That would be your base, and we would have to write it with parentheses. The other wrong answer would be 3x to the -5 to the 2nd. So what that's doing, that's wrong because you're squaring the 5 and then you're subtracting it from 3x. So this would be equal to 3x minus 5 times 5. And that's not what this says up here. So this is wrong. This is correct. We went over that. Number 3, what is the value of the expression 2a cubed minus the quantity of 1/2 b to the 4th plus 4 if a is 4 and b is 2nd? So we're going to substitute values in. Oh, darn. Okay. We're going to substitute values in for the variables. So we see that a is 4 and we see that b is 2. So let's rewrite that using it. That says 2 times a to the 3rd. The a value is 4 to the 3rd minus 1/2 times the b value, which is 2 to the 4th power plus 4. So orders of operations, we're always going to have to do exponents. Actually, we do parentheses, but those parentheses are some form of a grouping symbol. We could definitely do 2 to the 4th first. I'm okay with that. But this value here also doesn't affect that, so we can do that too. So 2 to the 4, 2 times 4 to the 3rd. 4 times 4 times 4, 16 times 4, I think is 64. Pretty sure, 16 times 4, 64, good. Minus the quantity of 1/2 times 2 to the 4th. That's 2 times 2 times 2 times 2, which I'm pretty sure is 16 plus 4. Notice I keep the parentheses there because we haven't simplified inside here. So we still have an operation this multiplication. So those parentheses still have to be there to separate things. We still want to do that. So 2 times 64 minus, and then half of 16. That would be the next step that we do. Half of 16 is 8 plus 4. So that negative just gets lopped onto what is inside those parentheses. Now we're going to do multiplication before addition and subtraction. So 2 times 64 is 128 minus 8 plus 4. We're going to do the subtraction before the addition because addition and subtraction are equal weighted in orders of operations, and we'll do it left to right. So that gives me 120 plus 4 is 124 would be my answer. Write 1 over 3 to the 9th power using a negative exponent other than negative 1. Okay, so negative exponents, we need to be aware of what they represent. So when we have 3 to the negative 2, that is 1 over 3 to the 2nd. That negative exponent really just changes. It's sort of like taking the reciprocal, but another way is, since this base, this 3, is in the numerator, when we change the sign of the exponent, when we change it from negative to positive, we're going to change the location. It goes from the numerator down to the denominator. So negative exponents really represent quantities or bases that are in the denominator. It's a nice and easy way of showing it in the numerator. So another idea, here we have, if you have 3 to the, no, it's not 4, let's do 3 to the 5th over 3 to the 2nd. And we had that dividing. That would be 3 times 3 times 3 times 3 over 3 times 3. And we know that 3 over 3 equals 1, 3 over 3 equals 1, and you end up with 3 times 3, which is 9, but we want to write it as an exponent, 3 squared. Well, there's a mathematical shortcut that tells us when we deal with exponents with like bases, these must be the same bases, must be like bases. When we divide, we subtract their exponents. So we could write that in the numerator, 5 minus 2. Oh, Mr. Mac, that wasn't 5. Hello, Miss. You probably already caught that. There needs, Mr. Mac, he does make mistakes. There should be 5 of them, so that should actually be 3 to the 3rd. Sorry. You probably already saw that and you said, wait a second, wait a second. You made a mistake. Yes, I made a mistake. I will make plenty of mistakes. But going back to this, let's make sure we circle that too. Good. So we have 3 to the 5 minus 2, which is 3 to the 3. So that's a shortcut. Instead of writing all those out, we do that. Well, that's when we have a bigger number in the numerator. What if we had 3 to the 3rd over 3 to the 7th? That would be 3 times 3 times 3 over 1, 2, 3, 4, 5, 6, 7. This time I got it right. And again, a 3 in the numerator cancels with a 3 in the denominator. 3 in the numerator cancels with 3 in the denominator. And we're left with 1 over 3 to the 4th. So notice we had an excess in the denominator. Well, if we use that subtraction technique, when we divide like bases, we can subtract their exponents. So if we have 3 to the 3rd over 3 to the 7th, that's 3 to the 3 minus 7, which would give us 3 to the negative 4. So notice these are equivalent. So that's what I mean, that negative exponent represents the value in the denominator. So those are equivalent, and that's what we mean when we write it. So this question, going back to this, when we have 1 over 3 to the 9th, we can write that as 3 to the negative 9. So notice it went from the denominator to the numerator, and we changed the sign of the exponent. It was positive 9, and now it becomes negative 9. So if we needed to write that as a negative exponent, we would write that as 3 to the negative 9. Let's look at another example. So if I have 3 to the negative 5, what does that equal? Yeah, 1 over 3 to the 5th. If I have 1 over 2 to the 7th, what does that equal? Yes, 2 to the negative 7. Here's the tricky one. What if I have 1 over 3 to the negative 6? What would that be equal to? 3 to the 6th. Good. Okay, that's a tricky one because you have a negative exponent in the denominator. So just some other examples for you to ponder. Write the product of the expression 5 to the 4th times 5 to the 7th using a positive exponent. Then write the product using a negative exponent. So much like when we divide, remember the example, when we divide like bases, we subtract, which gives us 2 to the 3rd. Well, when we multiply, so if you have 3 to the 4th times 3 to the 7th, that's going to equal 3 to the 4 plus 7. So division is subtraction, multiplication is adding the exponents, and that equals 3 to the 11th. So in this problem, and they must have like bases again, these have to be, must be like bases. So in this example, when we have 5 to the 4th times 5 to the negative 7th, we're going to add those exponents, which gives us 5 to the negative 3. Now, this is where it's tricky, using a positive exponent. So I have to change the sign of that exponent. If I'm going to change the sign, I have to change the location. So it's currently in the numerator. So in order to change the sign of the exponent, I have to push it down to the denominator. So that would be the answer using a positive, and then write the product using a negative exponent. So this would be the other answer. So negative exponent would be 5 to the negative 3rd. Positive exponent would be 1 over 5 to the 3rd. Write and evaluate an expression for the following statement. Write your answer using scientific notation. The quotient, division, of 10 to the 7th power, 10 to the 7th power, and 10 cubed. 10 cubed is 3. So we are dividing these two. So you would have 10 to the 7th divided by 10 to the 3rd. You could write it like that. Or you could write it 10 to the 7th over 10 to the 3rd. It's another form of division. So write and evaluate. So if we write that, it's going to look like that. And when we evaluate it, that means we want to simplify it. So I'm going to do 10 to the 7th divided by 10 to the 3rd. We have like bases and we are dividing them. So you can subtract their exponents, and that gives you 10 to the 4th. So you can leave it at that. I think that they want it as a power. Express it, write your answer using scientific notation. Ooh. All right, so scientific notation. So that is equal to 1 with 4 zeros. Now, if we want to write that in scientific notation, we would take this dot, because that's where the decimal point is, we would move it until this number becomes between 1 and 10. 1, that's 100, that's 10, it actually has to be less than 10, and it can be equal to 1. So we're going to move that decimal point to there. So scientific notation becomes 1 times 10 to the, how many places did we move? We moved 1, 2, 3, 4 places. So scientific notation for that would be 1 times 10 to the 4th. That's an interesting question. Lots of things to ponder. Write and evaluate the following statement. Write your answer using scientific notation. The product, that's multiplication, of 5 cubed to the 3rd, and 5 to the 4th. So we're multiplying those. Since we are multiplying like bases, we are going to add their exponents, which becomes 5 to the 7th. Write and evaluate. Write your answer using scientific notation. Again, so 5 to the 7th. So with my handy dandy notebook, right? 5xy, that's to allow me to do it to any power, to the 7th equals 78,125. 78,125. Again, we're going to take that number. My decimal point is there. I'm going to move it until it becomes a number between 1 and 10. That's 7,000. That's 781. That's 78.1. That's 7.8. So my number is going to become 7.8125 times 10 to the 1, 2, 3, 4. We moved it 4 spaces. Every space is a 10, a base 10 number. So that's why we do 10 to the 4th. All right, I think that's good. Write your answer using scientific notation. Yes. Scientists have discovered that many mammals expect to live for 1.5 billion heartbeats. Ooh, that's interesting. Write this number in scientific notation. So 1.5 billion means 1, and then so this is the 100th, 1000th, millionth, billionth. So 1.5 billion would be that number, and then we can 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that number is between 1 and 10. If I had it over here, that would be 15. That's not between 1 and 10. So I'm going to make it 1.5 times 10 to the 369. 3, 6, 7, 8, 9. And 10 to the 9th represents a billion also, if you want to take some shortcuts there. So it would be 1.5 times 10 to the 9th. The distance between Saturn and Mars is 7.53 times 10 to the 8 miles. The distance between Mars and Mercury is 8.37 times 10 to the 7th miles. Is Mars closer to Saturn or to Mercury? All right, the distance between, let's see this. All right, so we got Saturn. Saturn to Mars. So distance Saturn to Mars is 7.53 times 10 to the 8th. Good. And the distance between Mars and Mercury. So Mercury is going to be 8.37 times 10 to the 7th. So is Mars closer to Saturn or closer to Mercury? So it's closer to Mercury because this is 10 to the 8th and this is 10 to the 7th. So this number, because this number is relatively close to each other, we know that that's, this is adding a 0 and this is just adding a 1 in that place. So that's not that great of a difference. If this was 70, then we'd have to really do it out or think about it. So at this stage, we can look at which one has the lower base 10. So we know that Mercury, I didn't even spell that right, M-U-R-C-U-R-Y. Mercury is closer to Mars. The other way that we could do that is we could write this, let's move this down. Shucks. It's closer to Mars. Oh, look at me. I am making a mess of all this stuff. Okay, Mercury is close to Mars. We could just write that number out. That would be 7.53, And then the 8 tells us to move this decimal point right 8 places to the right. 1, 1, 2, 3, 4, 5, 6, 7, 8. And then we fill them in with zeros. So that number ends up being 753,000,000, comma, comma. So 753 million miles away. And Mercury is, let's keep moving stuff down. So we have space, proper space, and that's 8.37. This one we're only going to move 7. 1, 2, 3, 4, 5, 6, 7. Make the decimal point, add 5 zeros. So we get 837,000,000. 3, 3. What? I did it wrong. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 5 zeros, 5 zeros. Oh yeah, that's 753 million. This is only 83 million. So smaller. This is your answer. That is much smaller than 753. So Mercury is the answer. Sorry. What number is twice as great as 5 times 10 to the second? Oh. So if we have 5 times 10 to the second, that's 5. Put your decimal. You've got 2 zeros, 2 places, 1, 2. We add zeros in there. So that number is going to equal 500. What is twice as big as 500? 500 times 2 times 2 would give us 1,000. And if we wanted to write, we can write that as 1,000, or we could write it in scientific notation, which is 1 times 10 to the third, or you could see it as 10 times 10 to the second. Did you see that? If we only move this to 1, 2, because this is to the second, we notice that that would be 10 times 10 to the second, because you move 2 places. So we notice that we are able to just double that base number if we wanted to find it. But I would assume that they want this, even though it doesn't say write your number in scientific notation. That's a fun, tricky one. So they also might even want you to write that. But that's okay, either one. In 2010, the population of India was about 1.2 times 10 to the 9th. According to census data, the population of the United States was 308,745,538. About how many times greater was the population of India than the population of the United States in 2010? Okay, so what we can do is we can either expand one to standard notation, or we can convert them both to scientific notation. So if we take India's population, which is 1.2 times 10 to the 9th, which I don't know if you remember is a billion, but we would move that decimal point 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we add zeros in there. And every 3 0, you give a comma. So 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 3 places, 3 places, 3 places. So that is 1,200,000,000 for India. Now the US is 308,745, 538. All right, so how many more times? Well, you would look at both of these and you would see how much they go into it. Now your calculator is probably not going to take numbers into the billion. So this is where we're going to actually use scientific notation. So we're going to hold on to this value, and we're going to turn this value into scientific notation. We're going to round it a little bit. So our decimal point is here, 1, 2, 3, 4, 5, 6, 7, 8, because I need it between 1 and 10. So you get 3.0, we'll say 9. Let's even do 3.1 times 10 to the 3, 6, 8, I think we did. So you have, this is your scientific notation for US population, that's for India. So what you can do, we're going to do some advanced stuff, don't know if this is what they wanted, we're going to divide it. We're going to divide 1.2 times 10 to the 9th divided by 3.1 times 10 to the 8th. Okay, you also, the other shortcut is we can just chop off this and do 1,200 divided by 308. Looks like it's going to be about 4 times. There, I'm making this a little bit harder than it needs to be, but we've got lots of different ways to tackle this problem. So what I'm saying is you're negating each of the places, and you just, because those numbers will still be the same. You could actually keep going until you have, come on, you have 12. How many times 3 goes into 12? 4 times. That's probably the easiest way. But I'm going to show you some fun division with this. We can do this math problem. There's 2 things we're going to do. We're going to take the bases and we're going to divide those. So we're going to do 1.2, come on, 1.2 divided by 3.1 gives us 0.39. So 0.39 times, and then we're going to take this, and remember, when we have like bases dividing, we're going to subtract. That's 9 minus 8. So you have 0.39 times 10 to the first, and if we want to convert that to a standard number, we're going to take that decimal point and we're going to move it 1 place because of that, and we get 3.9 times greater. Okay, so you want to get a little bit more specific, 3.9, but you'd say approximately 4 times. India is 4 times greater than the United States. A lot of work on that one. Lots of different ways to tackle that, but food for thought. Sarah entered China's 2010 automobile sales into her calculator. The number appeared on her screen as 1.8 E6. Write this number in scientific notation and in standard form. Yeah, so the E just means scientific notation. It means 1.8 times 10 to the 6th. All right, so 1.8, I'd move it 6 places. 1, 2, 3, 4, 5, 6. And if that number was negative 6, then we'd move it to the left. We'd make the number smaller. Notice that we're making the number bigger when we move the decimal point to the right. So those are zeros. So you have 1, 8, 1, 2, 5, 3 places. So write this number in scientific notation and in standard form. Scientific notation would be 1.8 times 10 to the 6th. Standard form would be 1,800,000. That's a lot of automobiles. If y to the 3rd equals 729, what is the value of y? So what number cubed equals 729? What number times itself 3 times equals 729? Now, this would also, one of the other ways that you could figure that out is through logs. But you'll have to wait until high school. Maybe I think you're at Harvard-Westlake. Harvard-Westlake might actually go into logs a little bit easier. But you're going to look and see what number. So one of the things you need to understand is what number times itself 3 times is going to give us 9. So we're looking at numbers, right? You're not going to start with 1, you're not going to start with 2. But what number times itself 3 times, that base number, right? The ones place, the number in the ones place would produce a 9. So 3 times 3 is 9, but 9 times 3 would be 7. So 13 times 3 times 23, 3 times would give us 7 in the ones place. So 3 is not going to give it, 2 is not going to give it, 4. So, and it right, 4, 14, 24, so 16, and then 16 times 24 gives us also, what was it, 64. So I think that rotates 4 and 6, so that's not it. 5 is not going to be it. 6 is an interesting, 6, nope, that's always going to give us a 6. 6 times 6 is 36, and then you produce another 6. 7 was the one that I was thinking, just because 7 times 7 is 49, but 9 times 7 is 63, so that would end in a 3. 8 is 64, and then 4 times 8 is 2, so that doesn't work. Did we do 9? Oh, I bet you, maybe it is 9. Is 81, and then times 9. So let's try, so maybe it's a base 9, right? So maybe it's going to be 19. So let's do 19 cubed. Oh, nope, not 19. Let's try 9 cubed. 729. Should have stuck with it. So that is going to be 9 cubed equals 729. But notice how I was thinking about that ones place on what produces that ones place number. Hopefully you understood what I was doing there. The other way that you could have done it, and don't know if this is how you were supposed to do it, but 729. If we look at something like this, when you have 2x equals 18, well, let's not do 18 because I don't want you to think that 9. How do we get rid of, right? What's the inverse of the, we use inverse operation. So the inverse, what's happening to the variable that's 2 being multiplied by it? What's the inverse of multiplying? Is dividing. The inverse, right? So here's your operation and your inverse. So your inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. The inverse of division is multiplication. The inverse of squaring is square rooting. The inverse of square rooting is squaring. And then you can keep going. The inverse of a cube is the cube root. Fourth is the fourth root, etc. So we could look at this, and how do we get rid of a cube? Is you take the third root of that. So I would take the third root of 729. And one more thing to think of, when you see 7 squared, right, we think that that's an exponent. When you take the square root of 16, that can be written as a half root. So that's an interesting thing. Square root is equivalent to a half power, Square root is equivalent to a half power. And that's kind of another thing. So if you have 2 to the cube root of 2 to the 4th, you could write that as an exponent of 4 to the 3rd. This goes in the numerator, your root goes in the denominator. So we see that that is to the power of 1, that's in the numerator, that's in the denominator. Just interesting way of seeing powers or writing roots as powers, but so if your calculator, if you can't take the third root of something, oh, it does have a third root. So you could have just done 7, 2, 9, cube root, that gives you 9. But let's say if we wanted to know y to the 5th equals some value, right? Let's say 1056 or something crazy. And you wanted to find the 5th root, you could just do 10, 5, 6 to the 1/5 is equivalent to the 5th root of 1056. That might be a little too advanced, but that's one way. 2 ways of looking at it. Lots of math today. Find the square root of 64 minus the cube root of 64. Square root of 64 you should know. You should know all square roots, or what we call perfect squares, between 1 and 144. Those are given. You should absolutely know what those are by heart. what's that, 7, 8, 9, 10, 11, 12. Technically, you should know 13. That's an easy one. So these are called perfect squares. Perfect squares, 4, 5, 6, 7. You should know the square roots of all of these perfect squares between 1 and 13, 14, 12, 13. So when we see the square root of 64, we should know that's equal to 8. Cube roots you should know. You should know the cube root of 27. That one's relatively easy. Cube root of 8. So that is going to be, cube root of 64 is 4. But you can, again, go on your calculator, type in 64, hit the cube root, that equals 4. So you get 8 minus 4, which is 4. So that's how you can do that one. Between which two consecutive integers on a number line does the square root of 39 lie? Isn't that appropriate? Look at that. So we have these perfect squares, and it wants to know, where does square root of 39? Well, 39 is between the square root of 36 and 49. These are rational numbers, rational square roots. And so the square root of 36, square root of 49, so it's between 6 and 7 on the number line. So between 6 and 7, because 6 is the square root of 36, 7 is the square root of 49, and the square root of 39 lies in between those two. Okay? And 17, are all square roots rational numbers? No. Only perfect squares are rational, meaning they can be written as a fraction or a whole number. If it's not a perfect square, then it's considered irrational. So let's take a perfect square would be 36. So if we take the square root of 36, you get a rational number. If you take the square root of 2, which is not a perfect square, you get this irrational number. An irrational number is a number that never ends and never repeats. Even though it only goes to 5 on this calculator, that number continues on. So this would be considered an irrational. All non-perfect squares are irrational. All non-perfect squares are irrational. So that's actually the majority of square roots. The majority of radicals are irrational. It's a very few number that are rational, and those are the perfect squares. So irrational means non-repeating and what we call non-terminating. That means it doesn't end. Henry plans to enclose, so an example, counterexample would be the square root of 2. That would be 1. Square root, right? So if we start with the square root of 1, that would be rational. Square root of 2, irrational. Square root of 3, irrational. Square root of 4, rational. Square root of 5, irrational. Square root of 6, square root of 7, square root of 8 are all irrational. Square root of 9 is rational. Square root of 10, 11, 12, 13, 14, 15, irrational. So any number between, any radical square root between those perfect squares would be considered irrational. 2 more. Henry plans to enclose a square garden with fencing. The area of the garden is 400 square feet. How many feet of fencing does he need to enclose the garden? So it's a square one. The area is 400. So we know that since it's a square that the length and width are going to be the same. So x times x equals 400. That's how we find the area. Area equals length times width. So technically you have x squared equals 400. What number times itself equals 400? Or you can take the square root of 400. The area, yeah, good, right? 400, we can take the square root of that. So 400 square root gives you 20. So x equals 20. So each length is 20. How many feet of fencing? So you need 20 plus 20 plus 20 plus 20, or 20 times 4, which is 80 feet. It is linear. It is only feet of fencing. You need 80 feet of fencing. Okay, so the area is square feet. However, the fencing is one-dimensional. It's just going to be length. So your answer would be 80 feet. The mass of a proton is 1.672623 times 10 to the negative 27. So we know that we're going to be moving that decimal that way. That's talking about a really small number. The mass of an electron is 9.1095 times 10 to the negative 31 kilograms. Estimate the mass of each particle using scientific notation. Okay. Well, using scientific notation. Well, we already know the mass is already there. The mass of the proton is 1.6, blah, blah, blah. What is the approximate total mass of both particles? Total mass of both particles. And about how many times greater is the mass of a proton than the mass of an electron? So we know how to do that part. A and B I'm going to have to think about, and we're going to save that. I don't understand this question very well. Of both total mass. I don't know. This is very bizarre. But we're just going to do, we'll estimate that to 1.7 to the negative 27, and that's 9.1. So, and that is times 10 to the negative 31. That's times 10 to the negative 27. So we would, I don't know, 9.1 divided by 7, 9.1 divided by 1.7, 1.7 equals 5.4. 5.4 times 10 to the negative 31 minus negative 27. Notice that's where the tricky part is. 5.4 times 10 to the, that's going to be plus, that's minus 4. So that is 1, 2, 3, 4. Well, maybe we do 1.7 divided by 9.1 then. Let's do that. 1.7 divided by, oh, I got class in 2 seconds. 0.1 equals 0.1, 0.1.8. So let's do 0.2 times 10. And this time we're going to flip those around because I did. So that's negative 27 minus negative 31, which will give me a positive answer. I like that better. 0.2 times 10 to the 4th. Let's move that 1, 2, 3, 4. 1, 2, 3, 4. Add zeros in there. So it is 2,000 times bigger. And we'll talk about the other ones. I don't know how to stop it. How do I stop my filming? Where's my filming? Where's my filming? Did I really not film this all? Oh my goodness. It didn't film. Oh my goodness. Oh my goodness. Oh. Man, am I not happy right now. Hello, hello, how are you? Good. Hello, hello, whoa, admit. I didn't mean to admit all. Oh, hello, my lovely kitties. Oh my goodness. I can't believe. Oh, I'm so bummed. I just had a really bad thing happen to me. Really bad. Really unfortunate. I'll let you know. I'm waiting for everybody to come before I give you my horrible, horrible, very unfortunate news. Athena is here. Tiffany is here. Rory is here. Rock is here. Miles is here. Press is here. Press, did you tell your parents? Did you get my email?
Yeah, but it's just Hattie doing that.
Yeah. Well, it's both of you technically.
Yeah, I'll tell him.
I'm pretty sure that you want to graduate. Do you want a diploma? You want a diploma, don't you? Yeah. So we need both of you. Jordan is here. Liam is here. Kimmy is here. Hope is here. Ava is here. Yes, I see you, Ava. You're fine. Maya is here. Walter might be here. Jack is here. And Lucas is here. Christian is not going to be here. And my Simon Caps is tardy. And Simon is here. I just had, I think I've told you that I tutor people outside of school. I do it every now and then. I have friends that send me math questions. This one friend of mine I've been tutoring and working with, not really, I wouldn't call it tutoring. She like pops me questions every now and then. And I spent 3 hours the other day learning about nuclear half-life or nuclear waste and half-life and fusion and all this other crazy stuff that I hadn't seen for a bazillion years. And so I retaught myself because she had a question on it. So I like a good challenge. And so I spent the next 3 hours working on this one this one math problem. I had to open up a number of books. I had to go online. I had to watch a number of videos. And even though the first video didn't make any sense to me, I didn't give up. I could have easily have said, hey, you know what? I can't answer this question. This doesn't work for me. I don't remember what it is. But I like being challenged. And even though I don't know anything about, and this is like calculus stuff, and I don't remember it, I went and took the time to figure it out. I looked at problems and I ended up finding the solution. It was kind of fun. It was definitely challenging, but it was rewarding in the sense that it showed that I could complete and work through something that's difficult. I had another friend, this dad that we are friends. Our boys played lacrosse together, and their children go to Harvard Westlake. One's at Brown. The one that plays lacrosse with Shane is at Brown, but his other daughter, I think, she's a senior. And I worked with her throughout Harvard Westlake with math when I could. Now they have a younger child, and they reached out to me, and she sent me the study sheet. I just spent the last hour thinking that I was videotaping all of the solutions. I do my normal QuickTime videotape, etc.